Hello there, and welcome to Dreamy Science. Tonight we drift together through a universe so vast that your mind might just quietly give up trying to contain it. And that's perfectly fine. You're not here to calculate. You're here to feel small, in the best possible way. Out there, beyond your bedroom walls, beyond the hum of the ceiling fan and the glow of your phone, lies an ocean of light and silence that's been waiting 13 billion years for you to notice. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. It helps others find their way here. 2-1, sleepy soul at a time. Also, let me know your location and your local time down in the comments. I love seeing the little constellation of night owls around the world. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You begin, as all stories do, under a sky that you think you know. But tonight, something changes. You feel yourself rise, slowly at first, the air thinning around you like silk unraveling. The city lights fade to dust below. Clouds flatten out like silver ripples. You pass through that delicate blue halo that wraps the planet. The one so thin, it's almost embarrassing how fragile it looks from above. Astronauts always say Earth's atmosphere is paper thin. It's less than 1% the radius of the planet, a shimmering veil that separates breathing from vacuum. From up here, the sky doesn't look blue at all. It's a gradient, from deep cobalt to black velvet. The stars don't twinkle, they burn steady and cold. You can almost hear your heartbeat sync with the distant pulse of the planet below. Gravity is still tugging, but it feels weaker now, more like a suggestion than a rule. You imagine your body lightening, molecules spreading apart, unspooling into the dark. Scientists call this the Kwan line, about 100 kilometers above Earth. Cross it, and you're officially in space. Congratulations, you're now technically falling forever. You look down at the curved edge of Earth, glowing with a sunrise that's never still. It crawls along the horizon like a golden ripple, orbit by orbit, sunrise by sunrise, 16 of them every day on the International Space Station. 16 dawns, 16 dusks. If you tried to keep up with time here, you'd lose your mind faster than your sense of up and down. The air is gone now. Every breath you've ever taken feels precious. Out here, silence has a weight. Radio chatter crackles faintly from nowhere, and the vibration of your heartbeat becomes the loudest sound in the universe. The temperature around you swings wildly, from searing sunlight to a darkness so cold it bites like liquid nitrogen. You'd think it's peaceful, but space has its own kind of violence. There's still gravity here, of course. There's always gravity. That's the first trick space plays on you. It never really lets go. Even when you float weightless, Earth's pull still tethers you like an invisible string. The moon's tug joins in too, and even the sun, 93 million miles away, whispers its pull across the black. Everything, everywhere, is holding hands through gravity's invisible fabric. You can thank Isaac Newton for describing it, and Einstein for making it weirder. Einstein said gravity isn't a force pulling things together, but rather the bending of space-time itself. Imagine placing a bowling ball on a trampoline that's Earth. Drop a marble nearby, and it curves toward the dip not because the ball pulls it, but because the fabric tells it to roll that way. Now stretch that concept across 4 dimensions and try not to scream. Scientists still argue whether gravity might actually leak into other dimensions, which would explain why it's so much weaker than the other forces. Picture that. Tiny gravitons slipping through cosmic cracks, like shy particles ducking out of reality's party. You continue upward, past the reach of blue, past even the faintest trace of air. Sunlight becomes sharper now, pure and unfiltered, burning your retina if you stare too long. Your skin tingles from invisible rays, ultraviolet, gamma, cosmic. You realize that every living thing on Earth is shielded by that fragile blanket you just passed. One thin film of gas stands between a thriving world and the silent void. Space, it turns out, isn't that far away. It's just one bad jump from the top of your atmosphere. You glance sideways and catch the moon hanging there, close enough to touch, yet 400,000 kilometers away. It's funny how distance lies to your eyes. In space, everything looks both near and infinite. The moon reflects sunlight so perfectly, it almost feels alive, like it's watching. For centuries, humans stared back, wondering if gods or monsters lived there. Now we know it's mostly dust, basalt, and the occasional boot print. But that doesn't make it less magical. You drift farther, crossing the orbit of the ISS, where astronauts float in a tin can moving 17,000 miles per hour. They're constantly falling around Earth, missing it by a hair every second. You wonder if they ever tire of the view spoiler. They don't. They say the hardest part of returning home isn't gravity pressing them down again. It's missing the silence of space. One astronaut described it as the most beautiful loneliness. You pass satellites now, hundreds of them, blinking like distant fireflies. They form invisible highways of communication and surveillance, orbiting with precision so sharp that one rogue screw could cause a disaster. There's actually a name for that: the Kessler syndrome, a domino effect, where one collision creates debris that triggers more collisions until orbit becomes a deadly blender of metal shrapnel. Scientists still debate how long we can keep adding satellites before that chain reaction begins. You can almost hear the ticking clock above your head. As you drift higher, Earth shrinks into a glowing marble. The continents blur, the oceans swirl, and the thin veil of atmosphere glows electric blue. You suddenly realize this: everything you've ever loved, every laugh, every heartbreak, fits inside that tiny sphere. And you, for the first time, are outside it. It's humbling, isn't it? You probably won't survive long here, but while you do, it's breathtaking. Every rule of life you know, up, down, warmth, sound breaks apart in the vacuum. And yet, it's beautiful. So you let go. You stop resisting the vastness, and the vastness welcomes you back, like a quiet ocean accepting a single drop. You drift deeper into the black, and the stars begin to multiply, like someone gently turning up the brightness on the universe. You think you've seen stars before, but not like this. Down on Earth, the atmosphere scatters their light, softens it, hides thousands from view. But out here, the sky is saturated. Every inch of black seems alive with glittering pins, each one a sun, each one a story. The darkness itself feels crowded, but not in a bad way. More like you're lying in the middle of a silent concert that began long before you were born. Every star you see is old news. The nearest, Proxima Centauri, shines from 4 light-years away. The light hitting your eyes left when you were still figuring out the alphabet. And others? Their photons set out before humans even existed. The stars above you are really a museum of light, a display of cosmic fossils. You're looking into the past, billions of years old, still shimmering faithfully into your night. There's something poetic about it, isn't there? The fact that you never really see the universe as it is, only as it was. You're always catching up to light that's been running away from you since forever. Scientists call this the look-back time, and it's one of the reasons space feels so impossibly big. Even with telescopes like the James Webb peering into ancient galaxies, we're only glimpsing the past, never the present. The next time you look up at Orion's belt or the Big Dipper, remember this: those constellations are temporary alignments, drawn by coincidence. Stars in Orion are hundreds of light-years apart and drifting in different directions. In a few million years, that famous hunter's shape will dissolve, the stars scattering like spilled glitter. Space doesn't really do permanence. It just does illusion really well. One of the strangest illusions in the sky is starlight itself. It looks white to you, but most stars actually have color. Cooler stars glow orange or red, while hotter ones blaze blue or white. Our sun sits comfortably in between a cheerful yellow dwarf. That warm color that paints sunsets and summer days is just the byproduct of a mid-range stellar personality. There's a gentle comfort in knowing we orbit a star that's neither too calm nor too chaotic, though, in cosmic terms, it's still a ticking time bomb waiting to expand into a red giant someday. But that's 5 billion years from now. So, sleep easy. You blink, and one star catches your attention, flickering slightly. Maybe it's your imagination, or maybe it's one of the Cepheid variable stars that pulse like cosmic heartbeats. Their brightness swells and dims rhythmically, marking the passage of time across the galaxy. Astronomers actually use them as distance markers, standard candles, to measure how far away galaxies are. It's kind of adorable that the universe left us its own built-in measuring tape. Well, adorable in the same way a 100 million degree nuclear furnace can be. You remember learning that starlight can travel forever if nothing gets in its way. But that's only half true. Interstellar dust, tiny grains of carbon and ice can scatter, absorb, and even redden that light, like cosmic fog. That's why some stars appear warmer than they are. And somewhere out there, countless photons never make it at all, swallowed by clouds of dust. Light, too, has its limits. Even something traveling 300,000 kilometers per second gets tired eventually. Speaking of cosmic fog, astronomers recently discovered that the entire sky glows faintly with something called the cosmic optical background. It's like leftover light from every galaxy that's ever existed. Too faint to see individually, but strong enough to add a whisper of brightness to the darkness. The universe has a subtle afterglow, proof that even emptiness remembers being full. You let your gaze wander, picking out stars at random, and suddenly the thought hits. Most of those suns have planets. Statistically speaking, nearly every star hosts at least one. There are billions of Earth-like worlds out there, orbiting quietly in habitable zones where water might flow and creatures might dream. Maybe one of them is looking back, wondering the same thing about you. Maybe their bedtime stories are about us, the dim blue star from across the void. It's funny how space gives you both awe and anxiety in the same breath. For every beautiful thought, like the shimmer of ancient light, there's a cold realization. Stars die. They burn themselves out, shedding layers like cosmic onions until nothing's left but dense cores or black holes. Yet even that death isn't the end. Some stars go out with such ferocity that they create new elements: gold, silver, oxygen, the stuff in your veins. Every atom of iron in your blood was forged in a supernova. You are literally wearing starlight inside your body. Maybe that's why people can't stop staring at the night sky. It's like looking into a mirror that remembers your atom's birth. There's a romantic fringe theory out there, whispered about in astronomy circles. What if some of the stars we see are already gone, their light still crossing the gulf, while the star itself has died in silence? Scientists still argue whether that's technically true. For most nearby stars, the timescale is too short. If they vanished, we'd find out in a few dozen years at most. But for distant galaxies, it's practically certain. The light from them began its journey when dinosaurs ruled Earth. So yes, some of what you see isn't there anymore. You're gazing at ghosts. The Milky Way sprawls across your vision now, a river of stars cutting the night in half. From Earth, it looks like a faint cloud. From here, it's a spiraling cathedral of light. You realize you're not outside it. You're inside one of its arms, staring through billions of suns, stacked like glittering dust. The center of the galaxy glows faintly gold, wrapped around a supermassive black hole. You'll get there later tonight, but for now, you just float, surrounded by light that isn't quite light anymore. It's memory, fossilized in photons, whispering across impossible distances. There's no sound, no smell, no wind, only the steady flicker of radiation through the vacuum. It should feel lonely, but somehow, it doesn't. Maybe it's because every star you see is proof that chaos can shine, that explosions can nurture life, that time can stretch beauty into infinity. You're not lost your home, in the truest sense of the word. And as your eyes adjust to the deep dark, one last thought lingers like the aftertaste of wonder. Maybe the universe made stars not just to light the void, but to give lonely minds something to dream about while they fall asleep. You're floating now in that deep ink between the stars, and for a moment, it feels like nothing exists at all. But that's the trick of the void. It only looks empty. If you could hold out your hand and somehow count every particle around you, you'd find there's something everywhere, always. Space is not a vacuum in the way your kitchen counter is clean. It's more like an ancient ocean, deceptively still on the surface, but fizzing with invisible life underneath. You're surrounded by what scientists once called nothing, but modern physics knows better. Even in the most perfect vacuum we can imagine, tiny particles are popping into existence and vanishing again before you can blink. They're called virtual particles, and they're the universe's way of never being truly silent. For a fleeting instant, a pair of particles, matter and antimatter, appears, borrows energy from nothingness itself, and then annihilates back into the void. Poof, gone. It's quantum peekaboo on an unimaginable scale. Physicists have even given this phenomenon a name: the quantum foam. Imagine the smooth blackness of space magnified to a microscopic level. It would ripple like boiling water, constantly forming and collapsing in tiny fluctuations of energy. This vacuum soup fills every inch of the cosmos. It's so subtle that you can't see or feel it, but it's powerful enough to influence the universe's expansion. Some scientists believe this constant quantum chatter is what drives dark energy, the mysterious force pushing galaxies apart faster and faster. And yet, no one's really sure. The math works, kind of, but the numbers don't behave the way they should. When physicists calculate how much energy should come from all those virtual particles, the answer they get is wrong. Catastrophically wrong. The discrepancy is about 120 orders of magnitude, the biggest mismatch between theory and observation in all of science. It's so ridiculous that one researcher called it the worst theoretical prediction in the history of physics. Scientists still argue whether we're missing something fundamental, or if the universe is trolling us. Still, this strange quantum foam isn't just a curiosity. It leaves fingerprints. Take the Casimir effect, for instance. If you place two metal plates very close together in a vacuum, they'll mysteriously attract each other, even though there's nothing between them. That invisible pull is caused by virtual particles being excluded between the plates, creating a pressure difference from the outside vacuum. In other words, nothingness itself is pushing them together. Imagine that. The emptiness of space, gently squeezing metal like a cosmic hug. There's even a theory half serious, half poetic, that you could extract energy from the vacuum. Zero-point energy, they call it. If you could somehow tap into that endless flicker of creation and destruction, you'd have infinite power. The kind of energy that could make warp drives possible, or solve every power crisis forever. It's a lovely dream, the kind that fuels sci-fi and keeps grad students awake at night. But so far, no one's found a way to open that bottle without breaking physics entirely. Probably for the best. Humans can barely handle smartphones without drama. And the quantum weirdness doesn't stop there. Even photons, the same starlight you admired a moment ago, behave both like particles and waves, depending on whether someone's looking. That's right. Light changes its behavior based on observation. You can practically hear the universe smirking. If space were a person, it would be that mysterious friend who refuses to answer texts directly and somehow knows all your secrets anyway. Somewhere far off, a faint shimmer catches your eye. Not starlight this time, but something stranger. It's the glow of cosmic background radiation, the leftover warmth of the Big Bang, spread evenly across the sky. It's everywhere, even between the stars, a quiet, static hum that radio telescopes still detect. You're literally floating in the cooled remains of creation's first explosion, now just 3 degrees above absolute zero. Every square centimeter of space carries a faint whisper of that beginning. The universe, it seems, never forgets where it came from. You take a slow breath. Not that there's air here, but your body still remembers the rhythm. It's grounding, in a strange way, knowing that even the vacuum isn't truly empty. It's alive with fluctuations, ripples, probabilities. Some physicists even speculate that new universes could spontaneously appear from such fluctuations, given enough time and energy. If that's true, then reality itself might be just one bubble in an eternal quantum sea. Somewhere out there, maybe another you is floating in another space, thinking the same thought. Or maybe the thought came first, and the universe followed. Hard to say. Scientists still argue whether consciousness and quantum mechanics are distant cousins or just awkwardly acquainted. And you can't help but smile. For something so quiet, space is awfully talkative. Every tiny particle hums with potential, every void thrums with invisible energy. Even the darkness itself isn't truly dark. It's filled with motion, chance, and light too faint to see. The universe doesn't waste a single inch on nothingness. You drift through that restless silence and realize that what you're surrounded by isn't emptiness at all. It's potential. It's the blank page from which everything stars, galaxies, life arose. If that doesn't make your eyelids feel a little heavier, nothing will. You might as well close your eyes for a second. The vacuum will still be here when you wake up, bubbling softly, creating and erasing, dreaming in the dark. You open your eyes again, or maybe you never really closed them, and find yourself drifting in slow motion, your body aligned with the curve of Earth below. You're no longer rising or falling, you're orbiting. It feels like flying, but really, it's just falling forever and missing the ground every time. That's what orbit is, a continuous, elegant fall around a planet that never ends. Isaac Newton figured that out with a thought experiment centuries ago. He imagined firing a cannonball so fast from a mountain that as it fell, the Earth curved away beneath it. Fire fast enough, and the ball would never hit. It would just keep falling. Congratulations, you are that cannonball now. You glide silently above the blue marble, circling it once every 90 minutes. The view is hypnotic. Clouds rolling like silk, lightning flashing like camera bulbs in distant storms, auroras spilling green fire over the poles. From here, weather looks like art, not chaos. You begin to understand why astronauts describe orbit as addictive. They say it's the ultimate paradox, complete isolation and perfect connection, all at once. Down there, time follows the Sunday. Up here, it loops endlessly. You pass through day and night every 45 minutes. One side of the planet glows bright and warm, while the other falls into shadows so deep that stars reappear in sharp focus. You could almost reach out and scoop them up like glitter in ink. Your internal clock starts to give up, unsure whether it's morning, evening, or something else entirely. It doesn't matter. Space runs on its own schedule. Your body, however, is still complaining. In microgravity, blood and fluids drift toward your head. Your face puffs slightly. Your spine elongates by a few centimeters. You're literally taller here, but try not to brag. Your heart's working harder to keep circulation balanced. Astronauts describe it as living in a constant headstand. Still, it's peaceful in a strange, pressure-free way. There's no up or down, just drifting. The science behind that drifting is beautiful. You're moving roughly 7.8 kilometers per second, about 28,000 kilometers per hour, but it doesn't feel fast because there's nothing to measure speed against. You're free of air resistance, free of sound, gliding in a perfect dance between motion and gravity. The same force that wants to pull you down is also what keeps you here. It's a cosmic balance act that defines everything from your orbit to the path of the moon. Scientists still argue whether low Earth orbit will stay safe for long. With more satellites and space debris crowding the region, each fragment becomes a potential bullet. One loose screw can travel faster than a bullet and hit with 10 times the energy. NASA even tracks pieces smaller than a paint chip because a speck that size can tear through metal at orbital speeds. It's poetic and terrifying. the quietest place in existence, filled with invisible projectiles. But for now, you're lucky. The orbit is clean, the stars steady, the curve of Earth mesmerizing. You drift toward the dark side, and the sunlight fades like a dimmer switch turning down. The Terminator line, the moving boundary between day and night, slides beneath you, dividing the planet into gold and indigo. You pass over continents, cities twinkling faintly like constellations reversed. Humans have created their own artificial stars, little dots of resistance against the dark. There's a comfort in watching it all spin beneath you. Civilization becomes a glowing pulse, fragile, clustered, temporary. You realize that from here, there are no borders, no politics, no noise, just light, shadow, and the soft hum of orbital motion. It's as if space itself is gently reminding you how small human chaos really is. Somewhere beneath that cloud cover, people are looking up and wishing on a star, unaware that the star they see might be you. The ISS glides past every 90 minutes, visible for a few seconds before disappearing again. Down there, someone might whisper, "Make a wish," and up here, you almost hear it echo through the vacuum. Astronauts often say the strangest part of returning home isn't gravity, it's silence. Up here, silence has texture. It's thick, absolute, like a soft blanket that wraps around your thoughts. There are no birds, no wind, no distant cars, just the occasional hum of a system keeping you alive. It's both comforting and unnerving. You realize that if you screamed, the sound would die instantly, absorbed by nothingness. Not that you'd scream, you're too busy being amazed. Orbiting Earth isn't just science, it's philosophy in motion. You're constantly reminded that motion and fall are the same thing, just viewed differently. It's a gentle metaphor for life, really. You're always falling toward something, trying to find the right speed to stay aloft. One too slow, and you burn up. One too fast, and you drift away. Somewhere in between is balance. Out of the corner of your eye, you notice something glinting. A piece of frozen water, maybe, or debris reflecting the sun. It spins lazily beside you, flashing in rhythmic bursts. It's harmless, but it feels alive. A tiny reminder that space is full of travelers. Even discarded things move gracefully here. Nothing truly stops. Everything orbits something else, even you. Then you feel a faint tug, not physical, but emotional, as if the planet below is whispering for you to come back. You understand gravity in a new way now. It isn't just a force, it's connection. It's every atom in you calling to every atom in the world. You are bound not just by physics, but by belonging. Earth holds you, even when you're far away. Somewhere, your instruments flicker as you cross into Earth's shadow fully. The sunlight vanishes, total darkness. Then, as your eyes adjust, the stars multiply again 10 times brighter now, freed from solar glare. They look so close, you could step between them. For a heartbeat, you believe you could walk the orbit itself, stepping from light to dark, day to night, endlessly circling home. Down below, dawn is already crawling back across the horizon. You've completed one orbit, 90 minutes. 16 more sunrises await before the day is over. You smile. Time behaves strangely up here, bending not by relativity this time, but by wonder. If falling can feel this peaceful, maybe letting go isn't such a bad thing after all. You slip out of orbit now, pulled outward by invisible threads toward the sun, the star you've always known but never truly seen. From Earth, it's just a bright circle, too fierce to look at. But from here, it's enormous, regal, terrifyingly alive. It's not a gentle lamp in the sky. It's a roaring nuclear engine, spitting fire and light into every corner of the solar system. You feel its warmth even across 93 million miles. A reminder that every sunrise you've ever watched is just filtered violence. The sun is a perfect paradox, stable enough to nurture life, but chaotic enough to keep astronomers humble. Its surface, the photosphere, looks solid, but it's just a sea of plasma boiling at nearly 6,000 degrees Celsius. Underneath, fusion rages, hydrogen atoms smashing together to form helium, releasing energy that takes over 100,000 years to escape the core. By the time a photon from that inferno reaches your face, it's already older than human civilization. And here you are, catching it on your cheek as if it were new. Every second, the sun converts 4 million tons of matter into energy. You can't even visualize that 4 million tons disappearing in a blink, transformed into light that races through the void. It's a cosmic generosity unmatched. Yet even generosity has mood swings. The sun gets restless. Magnetic fields twist and knot inside it, building tension until a solar flare erupts. You see one now, a bright flash curling out from its surface like a dragon's breath. In a few minutes, a wave of charged particles will ripple through space at millions of kilometers per hour. A solar tantrum heading straight for the planets. When those storms reach Earth, they collide with the magnetosphere, our planet's invisible shield. Normally, Earth's magnetic field deflects the worst of it, steering radiation away like a cosmic umbrella. But sometimes, the solar wind hits just right, funneling particles toward the poles. They crash into oxygen and nitrogen in the atmosphere, lighting up the sky in curtains of green and pink. The aurora, nature's way of saying sorry for the geomagnetic chaos. From here, above the poles, it looks like a living river of light. It pulses, ripples, even dances. You can almost imagine it has a heartbeat. Astronauts say the aurora looks three-dimensional from orbit, curling like smoke through space. You reach out instinctively, knowing you'd never touch it, but you feel it anyway. A ghostly brush against your senses. Down on Earth, people look up at that same shimmer and think of magic. Up here, you know it's just charged particles and electromagnetic fields, and somehow that makes it even more magical. Scientists still argue whether our sun is unusually calm compared to others. Some nearby stars, so-called flare stars, erupt violently, blasting radiation hundreds of times stronger than anything our sun produces. If we orbited one of those, the atmosphere would be stripped away in days. The universe doesn't hand out safety blankets often. We're lucky enough to live beside a relatively polite fireball. Though, give it a few billion years, and it'll expand into a red giant big enough to swallow Mercury and Venus, and maybe us too. Don't worry, you'll have other things to do by then. A few decades ago, the Parker Solar Probe became humanity's first spacecraft to touch the sun, diving through its outer atmosphere, the corona. It moves faster than any object ever built. Over 600,000 kilometers per hour, wrapped in a carbon shield that can handle temperatures hotter than molten lava. Yet even it can only skim the edges, the same way you might run your fingers through surf but never dive into the ocean itself. The sun doesn't tolerate visitors. Still, its influence stretches far beyond its visible reach. You're moving now through the solar wind streams of charged particles, flowing outward from the sun in all directions. They shape the heliosphere, an enormous bubble around the solar system that deflects interstellar radiation. It's the sun's breath, extending billions of kilometers, keeping our cosmic neighborhood relatively calm. Without it, high-energy particles from deep space would rain down constantly, erasing atmospheres and frying anything with DNA. So yes, the sun throws tantrums, but it also keeps the monsters out. You glance back toward Earth. The magnetosphere glows faintly, shimmering as it deflects another gust of solar wind. It's like watching two invisible forces dance, a constant push and pull that protects life from destruction. For every peaceful night sky you've ever admired, there's a magnetic battle raging silently above you. It's a strange comfort, knowing that chaos has rhythm. You drift closer to the sun, enough to feel its presence like pressure on your skin. The light isn't just brightness, it's texture. It fills your vision, seeps through you, defines everything. The boundary between warmth and annihilation feels paper-thin. You're reminded that this same energy once fueled the earliest life forms, powered every tree, every breath, every heartbeat you've ever known. The sun isn't just a star, it's your ancestor. Every cell in your body is a descendant of its light. And then, a flicker one of those magnetic loops arcs upward, twisting and breaking free. You can almost hear it, though space carries no sound. If there were air, the flare would roar louder than any thunder. The burst expands outward, a halo of plasma called a coronal mass ejection. Somewhere out there, a satellite might flinch. Somewhere on Earth, a compass might spin wrong. Somewhere, an aurora is already blooming. You smile in quiet awe. The universe doesn't do calm, but it does balance. For every solar storm, there's an aurora. For every destructive wave, a breathtaking sky. And for every surge of light that leaves the sun, there's a planet like Earth waiting patiently to turn that chaos into life. As you drift farther from the golden glare, you realize that all of human history, every myth, every sunrise prayer, has been powered by this one glowing furnace. It's humbling, it's terrifying, and it's beautiful. You let the light wash over you, and for a moment, it feels like warmth itself is whispering goodnight. You drift beyond the reach of Earth's comforting glow, leaving the blue marble behind until it becomes nothing more than a pale dot tucked into sunlight. Ahead lies the true expanse of space, the quiet stretch between planets where nothing seems to move, yet everything is in motion. It's here that you meet the wanderers, the asteroids and comets, the cosmic drifters that tell stories older than the planets themselves. Imagine floating through a region of space called the asteroid belt, between Mars and Jupiter. You might picture a chaotic field of tumbling rocks colliding in every direction, like some Hollywood minefield of death. But in truth, it's vast and mostly empty. You could fly straight through without hitting anything. The average distance between two asteroids is hundreds of thousands of kilometers. You could easily slip between them without ever noticing. That's the thing about space. Even its clutter is mostly silence. Still, the asteroids that do drift there are ancient relics, frozen fragments left over from the birth of the solar system. They never managed to merge into a planet because Jupiter's immense gravity kept stirring things up, pulling and pushing until everything stayed broken. Each rock is like a fossil, preserving chemistry from the time when dust first became worlds. You drift closer to one now, a lumpy grey shape tumbling lazily through the dark. Its surface is a battlefield of craters and ridges, each scar telling a story of collision and survival. You can almost feel its solitude. It's been here for 4.5 billion years, basking in sunlight for a few hours, then disappearing into darkness for countless more. If rocks could dream, this one would dream of gravity, of being something larger, rounder, and alive. Scientists still argue whether water first came to Earth on comets or if it bubbled up from within our planet. You glide past a comet Naosi, brilliant, trailing a glowing tail of vaporized gas and dust. It's beautiful, like a frozen tear melting in sunlight. As it approaches the sun, its ices turn to gas, streaming out for millions of kilometers. From afar, it looks soft and delicate. Up close, it's pure violence. Jets of steam exploding from cracks in the ice, flinging dust into space like confetti. You watch the comet curve around the sun, a perfect arc in slow motion, before heading back toward the outer darkness. Its path is ancient and precise, calculated by physics and time. But there's something poetic about it, too, a kind of cosmic heartbeat. For centuries, humans looked up and feared these bright wanderers, seeing omens in their tails. Now, we send probes to chase them, eager to taste their secrets. In 2014, the Rosetta spacecraft landed on Comet 67P after a 10-year chase. It found organic molecules, carbon-based compounds that could be the ingredients for life itself. Imagine that. The same kind of chemistry that may have seeded the oceans resting on a frozen rock millions of miles from home. You pass clusters of smaller debris, now meteoroids, drifting quietly, waiting for gravity to pull them into some planet's atmosphere. Most of them will burn up in seconds, painting streaks across night skies for sleeping eyes that never realize how ancient their wishes are. Every shooting star you've ever seen was once part of something vast and old, perhaps a comet's dusty trail or an asteroid's fractured heart. Each one is a reminder that even destruction can be beautiful. Out here, you also encounter something more mysterious: the Trojans. These are asteroids, caught in Jupiter's orbit, leading and following the giant planet, as if locked in a gravitational waltz. They've been there for billions of years, trapped in perfect balance. Some are dark as coal, others gleam with metallic hints of iron and nickel. If you could land on one, the horizon would curve oddly, and the sun would hang still in a black sky that never truly brightens. You'd weigh almost nothing. You could jump, and it might take minutes before you came down. There's a rumor in science circles, one that sounds more like poetry than data, that the asteroid belt might hold the remains of a planet that never formed, or perhaps one that was shattered long ago. No one knows for sure. Some even imagine civilizations long extinct, leaving ruins there, fossilized in orbit. That's the sort of idea that keeps late-night scientists and dreamers awake. But so far, no alien ruins, only rocks, spinning endlessly through the dark. Still, those rocks might one day save us. Several asteroids contain more metal than all of Earth's mines combined. Iron, nickel, even platinum. future explorers might harvest them, turning ancient debris into the raw material for colonies and ships. Humanity might build its next home from the bones of failed worlds. There's something fitting about that cosmic recycling on the grandest scale. As you drift deeper into this rocky sea, you realize how delicate the balance is. Jupiter's gravity, immense and brooding, keeps this belt from chaos while simultaneously stirring it. Without Jupiter, those rocks might have joined to form another planet between Mars and itself. With it, they stay forever apart. Order through tension, creation through destruction. It's practically the universe's favorite theme. You notice one asteroid that glints brighter than the rest. Its orbit is odd, tilted, and elongated. Scientists once thought these were lost pieces of comets, remnants that have lost their icy layers but still wander like restless ghosts. The boundaries blur here. Comet, asteroid, meteor, just names for different moments in the same endless story. Every now and then, one of these space stones veers off course, nudged by gravity or light itself. Some fall toward the inner planets. A few even find Earth. You think of the dinosaurs for a moment. The 1 kilometer wide rock that ended their 160 million year reign in seconds. That asteroid struck with the power of 10 billion nuclear bombs. One moment, lush forests and giant reptiles. The next, a winter that lasted centuries. Yet, from that devastation came mammals, and eventually, you. Sometimes, the universe's worst moments are just the beginning of something new. The thought comforts you as you watch the comet's tail fade into black. Even in destruction, there's continuity. Every grain of dust from these ancient travelers carries potential metal, water, carbon, life's ingredients, drifting endlessly, waiting for a new world to call home. Out here, between planets, there's no sound, only light. The sun behind you glows faintly, and ahead, Jupiter's massive form begins to take shape. The asteroids fade behind like memories, spinning quietly in their endless waltz. You take one last look over your shoulder, and it strikes you. For all the chaos and collisions, the solar system feels astonishingly peaceful. Like a lullaby made of gravity and time, you float onward, deeper into the silence. The rocks shrink into pinpoints. The comet disappears into the dark, and you, tiny speck that you are, feel perfectly balanced between everything that has ever been destroyed and everything still waiting to begin. Jupiter rises ahead like a god disguised as a planet striped, stormy, and too vast to comprehend. Even from millions of kilometers away, you feel its pull, a low hum through the emptiness. If Earth is home, Jupiter is the neighbor you'd never dare to visit unannounced. It's the largest planet in the solar system, a swirling ocean of hydrogen and helium, so massive it could fit more than 1,300 Earths inside. Yet for all that size, it doesn't have a solid surface to stand on. Only endless atmosphere fading into metallic depths where pressure turns gas into liquid. You drift closer. Its cloud tops look like cream stirred into coffee bands of tan, orange, and white wrapped around the planet like ribbons. Each one spins at a different speed, creating storms that make hurricanes look like summer breezes. You've heard of the Great Red Spot. It's not just a famous eye in the storm. It's a hurricane 3 times larger than Earth that's been raging for at least 350 years. You could fly a jet into it and circle for weeks without finding an edge. The winds howl at more than 400 kilometers per hour, but from your silent perch in space, it looks oddly serene, just another slow swirl in the cosmic soup. Scientists still argue whether the Great Red Spot is shrinking or evolving into something new. Observations suggest it's been fading, maybe dying, though dying feels dramatic for a storm that's older than most human nations. Some theorize it's changing color because of chemical reactions in sunlight. Others think new storms are merging into it. Whatever the truth, Jupiter's face is never the same twice. It's a living planet of storms, a canvas painted by chaos itself. As you drift lower, lightning flashes within the clouds. These aren't ordinary flashes, they're enormous bolts stretching hundreds of kilometers, lighting up entire regions of the atmosphere. NASA's Juno spacecraft once recorded them glowing in blue ultraviolet bursts, like flashes from an underwater realm. Each strike releases more energy than anything Earth could generate. Yet here, they vanish almost instantly into the fog. You notice strange ovals and circular storms, pale and ghostly. Some are small cyclones swirling in delicate chains, others massive enough to engulf continents. Jupiter's poles, for instance, hide geometric arrangements of storms, perfect octagons and hexagons of whirling clouds, locked together by invisible forces. No one knows quite why they form those patterns. The universe, it seems, has a fondness for symmetry, even in chaos. There's a quirky fact you can't ignore. If Jupiter were only about 80 times more massive, it could have become a star. That's right. The difference between the solar system's largest planet and the smallest possible sun is just a matter of scale. In another universe, maybe Jupiter shines instead of reflects, and the night skies of its moons would glow warm and gold. But here, it remains a failed star, a cosmic, almost. Speaking of moons, you spot them now, dancing around Jupiter like a family of loyal attendants, 60-something moons and counting, though 4 stand out above the rest: Io, Europa, Ganymede, and Callisto, the Galilean moons, discovered by Galileo in 1610. Even through your visor, they gleam like gems. Io is the closest, and it's furious. It's the most volcanically active world in the solar system, its surface constantly reshaped by eruptions so powerful they can be seen from space. Imagine lakes of molten sulfur glowing red and gold, geysers of lava spraying hundreds of kilometers high. You'd think such violence would make it barren, but in a way, it's alive, a breathing, reshaping world. The reason? Jupiter's gravity keeps kneading it like dough. As Io orbits, it's stretched and compressed, its interior constantly churned by tidal forces so extreme that friction alone keeps it molten. Then there's Europa, your next stop. Smooth, bright, glacial. From here, it looks like polished marble streaked with brown cracks. Beneath its icy shell, scientists believe there's an ocean twice as much water as all of Earth's combined. It's kept liquid by the same gravitational kneading that torments Io, only gentler. Picture an entire ocean world hidden under kilometers of ice, heated by the push and pull of a giant planet. We don't know what swims there, if anything, but we suspect it could be the most likely place for life beyond Earth. Tiny microbes, maybe bioluminescent swimmers, glowing softly in eternal darkness. Somewhere under that frozen crust, life might already be humming quietly, unaware that the stars exist. Scientists still argue whether Europa's ocean connects to its surface through cracks and geysers. The Hubble telescope once spotted water plumes erupting hundreds of kilometers high. Proof, perhaps, that the moon occasionally exhales. If confirmed, it means future explorers could sample that ocean without ever drilling down, just by flying through the mist. Europa might literally breathe secrets into space. Ganymede comes next, bigger than Mercury, with its own magnetic field. It's the only moon in the solar system known to have one. Some regions are scarred and ancient, others are smooth, hinting at icy flows that once reshaped its face. Scientists think it too hides a subsurface ocean, possibly layered between ice and rock. Imagine a world where the ice could be thousands of kilometers thick, each layer whispering tales of epochs that never saw sunlight. And then there's Callisto, the distant, quiet sibling. It's heavily cratered, untouched for billions of years, the oldest surface in the solar system. If you want to see the universe's wrinkles, this is where you look. Some futurists even propose building human bases. There it's far from Jupiter's deadly radiation. Stable, serene, not a bad place for a cosmic retirement. You drift past these moons one by one, feeling oddly sentimental. Each tells a version of the same story, gravity's love letter to chaos. Without Jupiter's immense pull, none of these worlds would exist. Yet, that same pull makes them dangerous. Step too close, and Jupiter's magnetic field could fry a spacecraft's electronics in seconds. The radiation belts around it are lethal, buzzing with charged particles trapped by the planet's rotation. It's a beauty you can only admire from afar, like staring into a storm too big for comprehension. Down below, the clouds twist endlessly, glowing in reflected sunlight. You realize you could watch this for centuries and never see the same pattern twice. Jupiter is the solar system's beating heart of motion, a reminder that even in sleep, the universe never stops spinning. You float backward slowly, letting its vastness fade into the dark. Behind you, the other planets await, each with its own temperament. Jupiter lingers, a striped guardian, keeping the inner world safe by swallowing the asteroids and comets that might otherwise destroy them. In a quiet way, it's the solar system's shield, a cosmic bodyguard. You smile. Even the giants have their gentle side. As Jupiter fades behind you, a pale blue dot begins to shimmer ahead Saturn, the planet that somehow looks too elegant to be real. It's the poet's planet, the sculptor's masterpiece, the one that makes even seasoned astronomers sigh. You've seen it in pictures, maybe through a telescope once, those famous rings that look delicate enough to shatter at a whisper. But here, up close, it's impossible not to feel awe. The rings stretch out like spun glass, gleaming in sunlight, hundreds of thousands of kilometers wide, yet only about 10 meters thick. 10 meters that's thinner than a city bus. And still, they wrap the planet in an illusion of perfection. You approach slowly, drifting through the outer edge of the ring system. From a distance, it looks solid, like a single band of light. Up close, it's chaos. Millions of ice chunks and dust grains orbit in harmony, each reflecting sunlight like tiny mirrors. Some pieces are as small as sand, others as large as mountains. They crash and scatter and reform in a ballet choreographed by gravity. You could reach out and touch one of these icy fragments, though it would zip past faster than a bullet. Still, you imagine it an ancient snowball older than any mountain on Earth, glittering silently as it orbits the gas giant it calls home. Saturn itself looms beneath you, wrapped in bands of soft yellow and cream. It's made mostly of hydrogen and helium, just like Jupiter, but lighter, gentler somehow, as if painted in watercolor instead of oil. If you could place Saturn in a gigantic ocean, it would float. It's less dense than water, a giant balloon of gas and storms. Its winds, though, are fierce over 1,800 kilometers per hour, the fastest in the solar system. The poles are marked by strange hexagonal storms, geometric like Jupiter's, but sharper, more precise. Scientists still argue whether those hexagons are stable waves in the atmosphere or the result of something deeper, some hidden structure twisting the winds into patterns. Geometry itself would envy. You hover above the North Pole, staring into that six-sided eye. Clouds move in spirals, rotating around a calm center, an eerily symmetrical storm that's been spinning for decades, maybe centuries. The colors shift subtly, gold to beige to pale blue as sunlight filters through. It's hypnotic, the way nature sometimes arranges itself into perfect order just to remind you how little we understand. Saturn's rings hum faintly in the background, a soundless vibration you can almost feel through your fingertips. They're not static. They ripple, bend, and even sing in radio frequencies picked up by spacecraft. Cassini, the probe that once orbited Saturn for 13 years, recorded those eerie sounds waves generated by particles interacting with Saturn's magnetic field. If you could hear them now, they'd sound like the ocean meeting the wind, only lonelier. The Cassini mission taught us more about Saturn than humanity had learned in all of history before it. It dived through the rings, mapped their structure, and revealed that the rings themselves are surprisingly young, maybe only 100 million years old. That means they weren't born with Saturn. They might be the remnants of a shattered moon or a captured comet torn apart by tidal forces. In cosmic terms, Saturn got its jewelry late in life, a gift, or maybe a scar, depending on how you look at it. And speaking of moons, Saturn has over 80 of them, each stranger than the last. You drift toward one now, pale and gleaming Enceladus, small, icy, and quietly defiant. Its surface is pure white, brighter than fresh snow, reflecting almost all sunlight that touches it. Yet beneath that frozen crust lies another hidden ocean, kept warm by the same gravitational tug-of-war that keeps Europa alive. Cassini flew through geysers erupting from Enceladus's south pole and found water vapor, ice, and organic molecules, carbon, hydrogen, nitrogen, the ingredients of life. Imagine that, a tiny moon, less than the width of Texas, spouting ocean water into space like a cosmic fountain. If there's life anywhere beyond Earth, Enceladus could be whispering its breath into the void right now. Tiny microbes, maybe entire ecosystems, thriving in a sea under ice, warmed by nothing more than gravity and chemistry. It's a thought that feels both comforting and humbling. Then there's Titan, Saturn's largest moon, and one of the strangest worlds you'll ever see. It's the only moon in the solar system with a thick atmosphere, denser even than Earth's. When you descend through its orange haze, Sunlight dims to a muted glow. It rains there, but not water methane. Lakes and rivers of liquid methane and ethane dot its surface, shimmering like dark glass. There are dunes too, made not of sand, but of organic particles drifting down from the sky. Scientists have called Titan a frozen mirror of early Earth, a world that might echo what our planet was before life took hold. Scientists still argue whether Titan could harbor some form of exotic life, not water-based, but something that thrives in methane. It would be a chemistry we've never seen before, life rewritten by alien rules. NASA plans to send a drone there soon, the Dragonfly mission, a flying explorer that will hop from dune to dune, tasting the air, listening for secrets. The idea of a robot buzzing through orange twilight on a moon nearly 1 billion miles away feels like something from a dream. Saturn itself has mysteries too deep for any probe to fully solve. Deep below its clouds, pressures rise until hydrogen behaves like metal, conducting electricity, generating its magnetic field. No one knows exactly where the solid core ends, or if it even exists in the way we imagine. It's like staring into fog and trying to guess where the mountain starts. For all its beauty, Saturn is also impermanent. The rings you admire are slowly fading, falling inward as icy particles spiral down into the planet's gravity. Astronomers estimate that in about 100 million years, the rings may vanish entirely. One day, Saturn will look like a duller Jupiter, its brilliance gone. You imagine a far future sky where no one remembers the shimmering halo that once defined it, a silent disappearance in the long, slow rhythm of time. You drift above the rings once more, letting them gleam beneath you like ripples of frozen light. If you could lie down on one of those chunks of ice and close your eyes, you'd hear nothing but your own pulse, and maybe, faintly, the whisper of particles brushing past. Each speck of ice has traveled this orbit for millennia, never stopping, never colliding hard enough to break. They simply flow, like time. Saturn shrinks slowly behind you as you drift onward. The sunlight weakens, dimming from gold to pale white. Ahead lies darkness deeper still, Uranus, Neptune, and beyond them, the edge of everything you know. You take one last look at the glowing rings, and for a brief, wistful moment, they look almost alive, like something waving goodbye. You've grown used to the sun's light by now, the warmth that once seemed endless, but as you drift farther, it begins to fade. What was once brilliant becomes a pale spark, distant and cold. You're entering the kingdom of the ice giants now, Uranus and Neptune, the outer sentinels of the solar system. If Jupiter and Saturn were the fiery monarchs of motion, these two are the quiet philosophers, slow-turning, frigid, and strange. Uranus comes first. It doesn't shine like Saturn or blaze like Jupiter. It's subtle, serene sphere of turquoise mist, suspended in eternal twilight. You wouldn't even notice it with the naked eye from Earth, unless you knew exactly where to look. But up close, it's otherworldly. A pale blue-green glow ripples softly across its face, like sunlight through frozen water. The color comes from methane in its atmosphere, which absorbs red light and scatters blue. It's peaceful in a way that feels deceptive calm, but not still. Uranus spins oddly, very oddly. Unlike every other planet, it's tilted on its side, almost completely horizontal. Scientists think something massive once slammed into it long ago, knocking it askew. As a result, it rolls around the sun like a sleeping giant, its poles taking turns facing the star for 42 years at a time. Imagine standing near its equator. Your day and night would be the strangest rhythm imaginable. Years of daylight, followed by decades of darkness. No sunrise, no sunset, just a slow, endless fade. That same tilt makes Uranus's magnetic field behave like a drunken compass, tilted and offset from its center. Scientists still argue whether this strange geometry affects the planet's weather patterns. One thing's certain: Uranus has seasons unlike anywhere else. When sunlight finally hits the poles, after decades of night, the atmosphere stirs violently, storms and winds rising like a planet waking from a dream. You can almost imagine it stretching and groaning after a long cosmic nap. The winds here are deceptive. Though the planet looks placid, they whip across the upper atmosphere at nearly 900 kilometers per hour, enough to shred any aircraft to ribbons. Yet from afar, all you see is calm, a gentle blue world that hides fury beneath its surface. It's the ultimate cosmic introvert, quiet, unpredictable, and more complicated than it lets on. You float closer to the thin rings circling Uranus, faint, dark, and easy to miss. They're made of tiny chunks of carbon-rich material, not ice like Saturn's, which makes them nearly invisible. When sunlight hits just right, they shimmer like faint smoke trails. Astronomers didn't even know they existed until 1977. It's funny how something that big can hide in plain sight for so long. Space still keeps its secrets well. And then there are the moons, 27 of them, named not after Roman gods, but after characters from Shakespeare and Alexander Pope. Miranda, Ariel, Umbriel, Titania, and Oberon, each with its own flavor of weirdness. Miranda, the smallest of the major moons, looks like it's been torn apart and glued back together. Its cliffs rise 20 kilometers high, taller than Mount Everest and the Grand Canyon combined. Imagine standing at the edge of one, staring down into shadow so deep your mind refuses to process it. Some scientists think Miranda's shattered look came from violent collisions. Others believe internal forces resurfaced it. Either way, it's a patchwork world, stitched together by gravity and time. You drift away, leaving Uranus to its sideways solitude. Ahead, the sun dims even more, now no brighter than a distant lamp. The next planet waits in sapphire shadows, Neptune. It's deeper in color, a stormier blue than Uranus, richer, more intense. You feel the change immediately, like stepping from quiet water into a restless sea. Neptune's winds are the fastest in the solar system, reaching 2,100 kilometers per hour, nearly twice the speed of sound. The irony? No one fully understands how. The planet is so cold, around -220 degrees Celsius, that you'd expect its atmosphere to be sluggish. Yet something about its internal heat drives relentless motion. Scientists still argue whether this heat comes from leftover energy from its formation or from something stranger, perhaps gravitational compression, generating warmth deep within. The most famous feature here is the Great Dark Spot, a vast storm discovered by Voyager 2 inches 1,989. It looked like a darker cousin of Jupiter's Great Red Spot, though it's gone now, vanished within years. new dark spots have since appeared, wandering across Neptune's face like bruises on glass. The storms rise and fade without warning, giving the planet a moodiness that feels almost alive. Beneath the clouds, Neptune hides another secret. The pressure is so immense that scientists think carbon atoms may compress into diamonds. Literal diamond rain falling through the atmosphere. Lightning flashes may turn methane into soot, which then crystallizes as it falls, turning storms into glittering avalanches. You picture it, a thunderstorm of diamonds, tumbling endlessly into the dark. It's poetic and absurd all at once, the kind of beauty you can't write about without sounding like you're exaggerating. But nature rarely cares for restraint. Neptune's largest moon, Triton, circles the planet in the wrong direction, retrograde orbit, as if it was captured from elsewhere. It's colder than Pluto, yet somehow active. Geysers of nitrogen ice erupt from its surface, leaving dark streaks that stretch for kilometers. It's a frozen, whispering world, always facing Neptune, tidally locked, like a lover who never looks away. In its pale pink haze, you glimpse faint motion volcanic plumes rising and falling like breath. Triton shouldn't be alive, not this far from the Sunday. And yet, it is. Some astronomers believe Neptune once had more moons before Triton arrived. Its gravitational arrival may have thrown the others away, scattering them into the void. If that's true, Triton is both the guest and the conqueror moon that took everything when it came. You drift above Neptune's atmosphere for a moment longer, staring down into the layers of blue that seem to go on forever. If you fell through those clouds, you'd pass through hydrogen, helium, methane, then deeper still, through exotic ices and superheated water, where liquid and solid stop meaning anything. You wouldn't reach a surface, just denser and denser haze, until pressure crushed you into silence. Yet, it's strangely peaceful to imagine. The planet's calm isn't empty, it's infinite. As Neptune shrinks behind you, the sun becomes little more than a star, now bright, but not powerful. The solar system feels fragile, finite, like a snow globe set against eternity. Ahead lies darkness, pure and untamed. You're about to cross into the unknown, the region where planets end and mystery begins. You take one last glance back at the ice giants. They gleam faintly in the dying light, two silent sentinels watching over the edge of everything. Then, with a gentle breath, you drift beyond them, past the last whispers of warmth, toward the frozen frontier where sunlight dares only to dream. Beyond Neptune, everything changes. The warmth that once guided you fades into memory, and even the light, your oldest companion, becomes frail. The sun is now just another star among billions, though you can still feel its pull, faint but unyielding. You've entered the Kuiper Belt, a vast frontier of frozen relics, a cosmic scrapyard left over from the solar system's birth. Here, silence reigns supreme. The objects drifting through this expanse are ancient, older than Earth itself. They've remained untouched for billions of years, preserving the secrets of creation in their icy cores. You pass by one, a small, misshapen body tumbling slowly through the dark. Its surface is mottled red and black, a mix of methane ice and organic Tholin's chemical compounds created by radiation. It looks like an ancient ember floating in an endless night. And then, in the distance, you see something faintly pink. Pluto, once hailed as the 9th planet, now a dwarf. Pluto's demotion still stirs quiet debate. But titles don't matter out here. What you see before you is breathtaking, a world both fragile and defiant, orbiting at the edge of the known. Its surface glows faintly under the distant sun, a world of nitrogen frost and shadowed plains. To the human eye, it seems asleep, but under that calm veneer lies motion, activity, even change. As you draw nearer, the details sharpen. The surface isn't smooth, it's alive with texture. Vast plains stretch like frozen oceans, marked by strange polygonal patterns, cells of ice slowly rising and sinking, reshaping the landscape over millennia. Mountains of solid water ice rise as high as the Rockies, their peaks dusted with frozen nitrogen. Some shine like glass under the pale light, giving Pluto a ghostly radiance. The heart-shaped region Tumbor Regio comes into view. It's a frozen basin, wide enough to hold Texas and Oklahoma combined, named after Clyde Tombaugh, the astronomer who discovered Pluto in 1930. One lobe of the heart, Sputnik Planitia, is made of nitrogen ice that churns like a vast, slow glacier. You can almost imagine it breathing, expanding and contracting with Pluto's tenuous atmosphere as it freezes and thaws through its 248-year orbit. And that atmosphere, thin as it is, still dances, composed mostly of nitrogen, with traces of methane and carbon monoxide. It rises and falls with the planet's long seasons. When Pluto draws near the Sun, its surface ices sublimate, turning directly from solid to gas, forming a faint blue haze that stretches hundreds of kilometers high. The sunlight, scattered by tiny particles, gives the atmosphere its ethereal glow. It's faint, but it's beautiful, like the last whisper of a world that refuses to fade. You drift closer, and Pluto's largest moon, Charon, looms nearby, half its size, locked in eternal embrace. They orbit each other like partners in a slow cosmic waltz, bound by gravity so tightly that neither ever turns away. From Pluto's surface, Charon doesn't rise or set, it just hangs in the same spot forever. Together, they form a binary world, two souls tethered by distance and devotion. Charon itself is rugged and scarred. Its northern hemisphere bears a vast, dark stain. Mordor macular region coated in reddish tholins, possibly formed by gases escaping Pluto and settling here. Cracks and chasms cut across its surface, some hundreds of kilometers long, as though the moon once swelled and froze, tearing itself apart. You glide over one of them, watching sunlight spill into a canyon that could swallow Earth's Grand Canyon whole. In that frozen crevice, shadows stretch for kilometers, untouched for eons. Between Pluto and Charon lies a delicate bridge of matter-shared gravity, pulling particles back and forth in a dance of ice and dust. It's not visible to the naked eye, but it's there, faint and constant. You can almost feel it, a gravitational heartbeat echoing across the void. Beyond them, smaller moons Styx, Nix, Kerberos, and Hydra circle in chaotic orbits. They tumble unpredictably, spinning like tops. If you stood on one, the sky would never look the same twice. The light here is so dim that shadows fade into nothing, and time feels unmeasurable. Everything drifts, frozen yet restless. And still, you move outward. The Kuiper Belt extends far beyond Pluto, thousands of icy worlds, some as large as it, some even larger. Eris, Haumea, make names of gods and myths given to frozen ghosts. Some spin rapidly, others drift lazily, all locked in cold orbits that take centuries to complete. The sun is now a pinprick behind you, barely enough to cast a faint glow on your path. Eventually, even the Kuiper Belt thins out. The icy debris grows sparse, the darkness thicker. You're approaching the heliopause, the invisible boundary where the sun's influence ends, where solar winds slow to a whisper before giving way to the interstellar medium. It's a liminal place, a cosmic shoreline between the familiar and the unknown. Here, you pause. The faint hum of solar particles fades. For the first time, you are outside the sun's dominion. You've left the solar system. You've entered interstellar space. There's no sound here, no wind, no dust, only the quiet pressure of eternity. You think of Voyager 1, humanity's farthest messenger, drifting out here since 1977, still sending whispers back home across the endless dark. Somewhere, its golden record spins silently, a time capsule of music, greetings, and dreams. If an alien civilization ever finds it, they'll hear Bach, Chuck Berry, and a mother's voice saying hello in 55 languages. They'll know we once looked up and wondered. You look back one last time. The solar system is a fragile chain of light tiny dots suspended in black. From here, Earth is invisible. Everything you've known is gone, reduced to a memory of warmth. And ahead, only the galaxy. Stars spread out like grains of sand, billions upon billions. Some host worlds like ours. Most do not. Between them lies the void, dark, ancient, infinite. You drift forward anyway, drawn by the quiet promise that somewhere, in another sun's faint light, another traveler might be doing the same. The journey never truly ends. It only slows and softens and dreams. You drift deeper now, past the invisible wall that once marked the edge of our solar home. The temperature drops to nearly absolute zero, so cold that even atoms barely move. The darkness seems thicker here, older somehow. But as your eyes adjust, you start to see faint glimmers, tiny specks of dust reflecting light from stars unimaginably far away. You're moving through the interstellar medium, the thin haze of gas and dust that fills the space between stars. It's strange to think of it as matter at all. In every cubic centimeter of this vastness, there are only a few atoms: hydrogen, helium, maybe a stray molecule of carbon monoxide. Yet on a galactic scale, all that almost nothing adds up. It's the raw material from which new stars are born, the ashes of dead ones, recycled into future suns and planets. Space, it turns out, is the ultimate recycler. Every few light years, gravity gathers this gas and dust into clouds, some stretching for hundreds of light years. They're called nebulae, and they're where the magic happens. From a distance, they look like watercolor paintings, swirls of pink, green, and violet. But those colors are lies told by telescopes tuned to wavelengths human eyes can't see. What's real is the process inside, the slow, unstoppable collapse of matter under its own weight. Molecule by molecule, dust grain by dust grain, a star is forming. You enter one now, the Orion Nebula, perhaps the most famous nursery of them all. It's vast enough to swallow our entire solar system 1,000 times over, glowing faintly in hues of blue and crimson. The light you see is the energy of newborn stars ionizing the surrounding gas. Every flicker and ripple is a birth cry, a pulse of ultraviolet light carving cavities into the mist. You glide through it slowly, feeling the scale of it press against your imagination. The nebula hums not with sound, but with light. It's alive in a way silence could never be. In the denser regions, gravity tightens its grip. Clouds condense into knots, and the knots collapse further until heat and pressure ignite nuclear fusion. A new star is born. You can almost feel the first flare as it erupts. Hydrogen atoms fusing into helium, releasing energy that will shine for billions of years. It's humbling, this endless cycle of death and rebirth. Every atom in your body, in every living thing that ever was forged in such a star. You are, quite literally, stardust that learned to dream. A gentle reminder drifts across your thoughts. Stars don't live forever. Even now, within this same nebula, other stars are dying, exploding in supernovas, scattering heavier elements like iron and gold across space. Those remnants will someday seed new worlds, perhaps with life of their own. It's an endless relay race of creation, and you're floating right through the middle of it. But it isn't all calm and beauty. The nebula is a turbulent place, full of shock waves and radiation storms. Jets of plasma shoot from young stars at nearly light speed, carving tunnels through the gas. It's chaos disguised as art. And yet, within that chaos, structure emerges. Protoplanetary disks forming around infant suns, dust grains clumping into pebbles, pebbles into worlds. It's the quiet beginning of another solar system. Maybe one like ours. Maybe better. Scientists still argue whether life could arise in such environments, shielded within the dark cores of nebulae or hitching rides on icy comets ejected from them. There's even a theory still fringe but fascinating that life might not have started on Earth at all, but elsewhere, carried here on cosmic debris. Panspermia, they call it. The idea that the seeds of life drift through the galaxy, waiting for a home. If true, then somewhere out there, other Earths might already exist, teeming with familiar chemistry, built from the same ancestral dust. You move deeper into the cloud, and everything grows thicker. Wisps of hydrogen and helium flow past you like slow fog. If you listen closely, not with ears, but with imagination, you can almost hear the resonance of ancient atoms colliding, their tiny impacts echoing across eons. It's soothing in a strange way, like the faint hum of a refrigerator a million miles away. The cosmos has its own ASMR. Ahead, you notice something darker, a region where light seems to vanish entirely. This is a Bok globule, a dense pocket of gas and dust so thick it blocks starlight. Inside, hidden from view, another star is forming, slowly gathering mass from its surroundings. One day it will shine like the rest, but for now, it slumbers. You can almost envy it, the quiet of that gestation, the calm before the burning. Then, like a breath being released, the nebula thins. You emerge from the glowing mist, and see a field of newborn stars before you, clusters glittering like spilled diamonds. Some are surrounded by glowing halos, others already shedding their nursery gas, stepping out into the galaxy as young adults. It's a cosmic coming-of-age ceremony, silent but spectacular. You pause for a moment, letting your gaze wander among them. Each one is unique, different size, different color, different destiny. Some will live for billions of years, slow burning and stable. Others will blaze hot and die young, their brief lives marked by violent beauty. And among them, perhaps, are stars, with planets already forming tiny specks of potential, waiting to be noticed. As you drift on, the nebula fades behind you, leaving a faint pastel glow in your wake. Ahead lies open space once more, but now you know it's not truly empty. It's full of possibilities, of raw materials for the next act of creation. You think of how everything you've seen, the galaxies, the stars, the atoms themselves, are just expressions of the same ancient forces, repeating in infinite combinations. Gravity, time, and energy, playing their endless game of hide and seek. And in that realization, something soft settles in your chest. You're not just floating through the universe, you're part of it. Every breath, every heartbeat, every quiet thought is another echo of this same cosmic rhythm. You don't observe the universe, you participate in it. You are it, so you drift, calm and weightless, in a sea of light and dust, while newborn stars flicker around you like candles waiting for names. You're not just floating through the cosmos anymore. You're moving with it. Each particle of your being seems to vibrate in tune with the rhythm of the galaxy. The stars ahead blur into a gentle smear of light as you approach one of the Milky Way's grandest features, the spiral arms. From far above, they would look like the graceful sweep of a dancer's skirt, curling elegantly around a glowing center. But from your perspective, drifting within one, it's a forest of light, a jungle made of suns. You're crossing the Orion Arm, the same spiral segment our own solar system calls home. It's small compared to the others, tucked between the Sagittarius and Perseus arms, but it glows with life. Each star you pass could host its own system of planets, its own miniature drama of creation, evolution, and maybe even consciousness. Some burn bright and white, like Sirius the dog star, only 8.5 light-years from Earth. Others are red and cool, older than civilization itself, their light soft as candle flame. And then there are the giant blue superstars, whose radiance outshines entire clusters. They're the show-offs of the galaxy, burning furiously and dying young, like cosmic rock stars who refuse to fade quietly. You watch one pulse in the distance, its outer layers trembling as it nears the end of its life. Scientists still argue whether some of these massive stars collapse directly into black holes or explode first in supernovae. Either way, their endings seed the galaxy with the ingredients of everything: carbon, oxygen, iron, gold, death, in service of beauty. Between these brilliant lights, there's more emptiness than presence. Yet that emptiness holds structure. Vast filaments of gas and dust stretch like ghostly tendrils, connecting stars across light years. Magnetic fields twist through them, shaping the clouds into arcs and feathers. The entire arm seems alive, breathing slowly through cosmic lungs. You can almost sense the heartbeat of the Milky Way itself, one pulse every 200 million years, the time it takes for our solar system to orbit the galactic core once. You're part of that orbit now, gliding alongside billions of companions, though companions is a generous word. The nearest star to you might still be several light years away. The scale is incomprehensible. You could travel for 10,000 human lifetimes and never reach the next one. And yet, the galaxy holds together, gravity's invisible hand, keeping everything in slow, graceful motion. Somewhere in this ocean of stars, you pass through a region of quiet mystery, the inter-arm gap. It's darker here, lonelier. The density of stars drops, replaced by faint molecular clouds and the faint shimmer of background radiation. You feel smaller here, almost erased, as if the universe takes a breath between its grand sentences. It's in these silent intervals that your thoughts wander freely. You wonder if other civilizations drift somewhere out there, tracing the same spirals in their night skies. The Drake equation once tried to estimate how many intelligent beings might exist in our galaxy. Depending on your optimism, the answer ranges from a few thousand to just us. Scientists still argue whether the silence we hear means we're early, we're alone, or we're simply not listening the right way. The Great Filter theory even suggests that civilizations might self-destruct before mastering the stars, a dark thought that somehow feels too human to be universal. But then again, maybe life thrives quietly, unnoticed, content to exist without needing to broadcast its presence. Perhaps the galaxy hums with minds that look nothing like ours, using senses we can't imagine, speaking in light or magnetism instead of sound. Somewhere, maybe right now, another being drifts through its own spiral arm, wondering the same thing about you. You catch sight of a nebula shaped like a great bird, the Eagle Nebula, home to the famous pillars of creation. Those towering columns of dust stretch for light years, sculpted by radiation from newborn stars. You drift closer, and the detail sharpens. The edges glow faintly where ultraviolet light ionizes hydrogen gas. Inside, stars are forming even now, hidden from view. Every atom of your body once passed through such a place, a quiet reminder that even the grandest vistas of space are built from humble beginnings. And then you look toward the galactic center. It's still hundreds of light years away, but the glow is unmistakably a dense, swirling brilliance like molten gold. Billions of stars pack the core, orbiting a common center that no light can escape. Sagittarius A*, the supermassive black hole at the Milky Way's heart, sits there calm, ancient, endlessly hungry. 4 million times the mass of our sun, yet invisible. You feel its presence like a pressure on your thoughts, a gravitational whisper tugging at the edges of perception. The stars closest to it whip around at blistering speeds, caught in a dance that's lasted since the galaxy's youth. Some are devoured, others are flung outward, exiled to the galactic halo. The black hole feeds on gas clouds, growing slowly, patiently, and around it, magnetic fields twist like ribbons, guiding jets of charged particles that sometimes shoot light years into space. It's chaos and order, fused into one timeless engine. You pause to imagine what it must look like up close. A vast glowing disk of gas spinning faster and faster, heating to millions of degrees, before vanishing past the event horizon. It's the universe's most perfect mystery, the place where gravity wins, where time and space themselves give up trying to make sense. If you could hover just outside, you might see light bending in impossible arcs, stars looping back on themselves in optical illusion. Beautiful, terrifying, sleepy, and you can't help but chuckle. Even out here, at the edge of knowledge itself, the universe still plays coy. Every answer births a new question. Every mystery solved reveals another, deeper one beneath it. Maybe that's what keeps everything moving. Curiosity, written into the laws of physics. As you drift onward, you realize that the spiral arms aren't static. They're waves, patterns of density, not permanent structures. Stars move in and out of them, born in the bright regions, aging into the dark. The arms aren't solid. They're more like traffic jams in the grand highway of stars. Everything flowing, everything changing, and somehow it all holds together. You take one last look back at the glowing band stretching behind you. Billions of stars, countless stories, all woven into a single luminous curve. The Milky Way isn't just a galaxy. It's a memory in motion, a slow cosmic river carrying you and everything you've ever known toward whatever lies beyond. The journey continues. The stars hum softly, and you drift through their song. You're not just floating through space, you're part of it, a participant in the grand choreography of existence. Every atom that makes up your thoughts was once light, once plasma, once dust drifting between stars. And someday, it will be again. That understanding sinks in slowly, like warmth spreading through the void. The boundaries between you and everything else begin to blur. There's no out there anymore, only the endless continuum of matter and motion, expanding and collapsing in perfect balance. You close your eyes, or maybe you don't need to. The darkness feels softer now, as if the universe itself is breathing with you. Each inhalation draws in starlight. Each exhalation releases it. You and the cosmos are one long, slow breath. For a moment, everything stops. Time, motion, even thought. There's only the quiet hum beneath existence, the gentle pulse that keeps it all alive. You could stay here forever, adrift among stars unborn and stars long dead, at peace in the infinite lull between them. Then, faintly, a ripple stirs in the black, another light distant but growing. The next chapter of the universe is calling, and you drift toward it, weightless and calm, ready to dream deeper still. You glide toward that growing ripple of light, and slowly, the darkness parts like a curtain. Ahead, an entire city of stars comes into view, the dense, swirling heart of the Milky Way. You've left the quiet outskirts behind. Now, you're entering the galactic core, a place so packed with energy, it almost feels alive. Here, stars crowd together by the millions, their light overlapping into a golden haze. The airless void between them shrinks to mere fractions of a light year. If you were standing on a planet here, assuming any could survive, it would never know true night. The sky would shimmer endlessly, a perpetual dawn. But in truth, not much life survives this close to the center. Radiation bathes everything, and gravity twists space into strange geometries. Still, you can't look away. You feel the pull of Sagittarius A*, the supermassive black hole that anchors the galaxy. It's invisible, but you sense its presence like a silent drumbeat in the dark. 4 million suns worth of mass crushed into a single point so dense that even light itself cannot escape. Around it swirls an accretion disk of gas and dust, glowing white-hot as it spirals inward. Every revolution marks another moment of cosmic sacrifice matter, surrendering its form to the endless curve of space-time. As you drift closer, the view becomes surreal. Light bends in looping arcs, stars appear where they shouldn't, and shadows twist into impossible shapes. You're seeing space, as Einstein described it, warped, stretched, and folded by gravity. Scientists still argue whether time itself stops at the event horizon or simply loses meaning there. One thing is certain: once something crosses that line, it never returns. Except, perhaps, in theory, or memory, or the math that tries to make sense of it all. You pause just beyond that shimmering threshold. The accretion disk hums with lethal beauty, spinning faster than the eye can follow. If you could hear it, it would roar with frequencies too deep and ancient for human ears. But in this silence, it feels almost tranquil, a place of endings and beginnings, balanced perfectly on the edge of forever. You notice something remarkable: jets of light and matter shooting out from the black hole's poles, extending for thousands of light years. They pierce the surrounding gas like spears of radiance, lighting up the galactic core. Scientists believe these jets are powered by magnetic fields twisting at near light speed, hurling particles into space. The scale is unimaginable. Each jet carries enough energy to outshine entire galaxies, yet here they are, mere byproducts of gravity's appetite. And yet, for all its violence, the core isn't chaos, it's structure. Every orbit, every filament of plasma, every ripple in space-time is part of a vast equilibrium. Even destruction here has grace. You watch a cloud of gas fall inward, stretch into a glowing ribbon, and vanish into the horizon. In that instant, it becomes part of something larger, a contribution to the slow heartbeat of the galaxy itself. Somewhere nearby, stars orbit the black hole in reckless proximity. Astronomers have tracked one of them, S2, whipping around the core once every 16 years, at speeds exceeding 5,000 kilometers per second. You try to imagine that a sun moving so fast that time bends around it, its light red-shifted by sheer velocity. Observing it was how scientists confirmed Einstein's predictions about relativity. The universe, it seems, doesn't just follow his equations, it flaunts them. You glance outward again, beyond the glare, where the galactic bulge tapers off into a sea of stars. The Milky Way stretches in every direction, arms spiraling outward like the slow whirl of a cosmic hurricane. Billions of suns, each with its own story, each surrounded by dust, rock, maybe even oceans. It's dizzying, but also comforting. Even here, amid the most extreme forces imaginable, the same fundamental laws apply, the same dance of gravity, light, and time that shaped your own home sky. And yet, a thought lingers. What lies beyond the galaxy? Beyond all galaxies? Scientists still argue whether the universe is infinite or simply very, very large. Some think space curves back on itself, like the surface of a balloon, travel far enough in one direction, and you might return to where you started. Others believe it expands endlessly, creating new regions faster than light can bridge them. You'll never know for sure, but that uncertainty is strangely peaceful. Some mysteries are meant to stay soft at the edges. You drift a little farther from the core, watching as the stars thin again. The radiation fades, replaced by a calmer, cooler emptiness. Behind you, the galactic heart pulses on, patient and steady. Ahead, you can see faint smudges in the distance other galaxies, vast and unreachable, each a glowing island in a black ocean. The scale is absurd. The nearest, Andromeda, is more than 2 million light-years away, yet it shines bright enough to be seen from Earth with the naked eye. Someday, the two galaxies will collide, merging into a new one entirely. But that won't happen for another 4 billion years. A long time even by cosmic standards, plenty of time for more stars to be born, live, and die. Plenty of time for everything, really. You can't help but smile. Somewhere back home, someone might be looking up right now, pointing at the faint blur of Andromeda in the sky, not realizing they're seeing their galaxy's future. Or maybe they're watching this very story unfold, letting it lull them to sleep. Either way, it's a reminder. Everything is connected, from the atoms in your breath to the light of the farthest quasar. You take one last, slow look at the galactic center before turning away. Its light follows you for a while, soft and golden, until it becomes just another star among billions. The Milky Way hums gently in your wake, spinning its eternal spiral, while you drift on calm, small, and infinite all at once. You drift beyond the familiar halo of the Milky Way into intergalactic space, an expanse so vast that even light seems to hesitate. The stars thin, then vanish, until there's nothing left but the faint glow of distant galaxies. It's not darkness, exactly more like the silence between thoughts, the pause between heartbeats, a kind of infinite calm. Here, space stretches almost perfectly smooth. The nearest particle of matter might be meters, or even kilometers, away. Time feels slower, softer. It's easy to forget direction, or even the concept of where. You're adrift in what scientists call the cosmic voids, immense regions of nothingness that make up most of the universe. The galaxies, for all their grandeur, are just filaments and clusters on the edges of this emptiness, like frost on a window pane. You move through this stillness for what feels like forever, and then almost imperceptibly, something changes. A faint shimmer ahead, another island in the dark. It grows slowly, revealing itself as a galaxy cluster, a gathering of thousands of galaxies bound together by gravity. Some spiral like the Milky Way. Others are elliptical, smooth, featureless orbs of ancient stars. Together, they form a structure so immense that light takes millions of years to cross it. These clusters are not peaceful places. Between their galaxies floats a superheated plasma, millions of degrees hot, glowing faintly in X-rays. And unseen, woven through it all, is dark matter, a mysterious substance that makes up most of the cluster's mass. You can't see it, but you can feel its influence, tugging gently at everything around. Scientists still don't know what dark matter is. It doesn't emit light, doesn't absorb it, doesn't interact with normal atoms in any obvious way. Yet without it, galaxies would fly apart, unable to hold themselves together. You drift closer to the cluster's center, where the largest galaxies lie. Some of them are monsters 10 times the size of the Milky Way, their halos merging, their stars mingling like overlapping waves. These are cosmic cities, built from the wreckage of countless mergers over billions of years. In their hearts lurk black holes so massive they make Sagittarius A times look small. Some weigh billions of suns. They feed slowly now. Their accretion disks dim, but the scars of their younger, hungrier days remain. Jets of radio waves stretching across intergalactic space, like fossilized lightning. As you watch, a thought drifts through your mind. All of this, the stars, the galaxies, the clusters, is just a thin film on the surface of something larger. The universe has structure on unimaginable scales. Galaxies form filaments, filaments form walls, and between them lie the voids. Together, they create what cosmologists call the cosmic web, a vast, interconnected network that spans the entire observable universe. If you could step far enough back, it would look almost biological, like a brain or a neural map glowing softly in the dark. Perhaps, in some poetic way, the universe is thinking its thoughts written in gravity and light. You drift along one of these filaments, feeling the pull of gravity weaving through space. Each node, each intersection, is a galaxy cluster like the one you just left. Between them, long tendrils of dark matter guide the flow of gas and stars, shaping everything. It's humbling, realizing how delicate and ordered it all is. Randomness? Yes, but guided by laws so precise they might as well be music. Eventually, you slow. Ahead, you see something faint but unmistakable, the edge of the observable universe. Not a wall, not a boundary, but a horizon. Beyond it, light has not yet had time to reach you. The universe is about 13.8 billion years old. But because space itself is expanding, that horizon now lies roughly 46 billion light-years away. Everything beyond remains hidden not because it doesn't exist, but because it's simply too far for light to have arrived. You stare into that dim glow, the afterimage of creation itself, the cosmic microwave background. It's faint and ancient, the remnant radiation from the Big Bang, stretched by billions of years of expansion, until it now hums softly in microwaves. It fills all of space, evenly, like a cosmic whisper. Scientists call it the oldest light in the universe. To you, it feels like a memory worm, faint, and impossibly distant. And in that moment, you understand something profound. You are looking not at the edge of the universe, but at its beginning. Every atom, every star, every thought traces back to this point, to a time when all of space was compressed into a single blinding instant of creation. The same hydrogen that fuels stars, the same oxygen that fills your lungs, was born here. The universe hasn't just expanded, since then it's been unfolding, like a flower in slow motion. You let the silence wash over you. No up, no down, no near, no far, just the soft hum of background radiation and the infinite, gentle expansion of everything. In that stillness, you feel something almost human gratitude, maybe, or awe. The understanding that to exist at all, in a cosmos this vast and improbable, is already the rarest miracle. You close your eyes, or whatever passes for eyes in this endless dark, and breathe out slowly, even though there's no air. For a moment, it feels like the universe breathes with you. The same rhythm, the same calm, the same endless unfolding. You stay near the faint hum of the cosmic microwave background for a while, floating in that oldest light. The waves are so uniform that any variation, a tiny dip or rise in temperature, is like a fingerprint left over from the very first fluctuations of existence. These ripples, though small, eventually became galaxies, stars, and everything else. Without them, the universe might have stayed perfectly smooth, a silent, endless soup of hydrogen. Imperfection, it seems, is the reason anything beautiful exists at all. A nice thought to drift on. You continue outward or perhaps inward, because at this point, direction is meaningless. The expansion of the universe carries you like a leaf on an invisible tide. Each moment, galaxies drift farther apart, not because they're moving through space, but because space itself is stretching between them. It's a quiet separation, one you barely feel, but it never stops. One day, countless eons from now, even the faint glow of other galaxies will fade from view. Future astronomers, if any still exist, will see only darkness and their own lonely stars. You imagine that distant future. Stars burn out, planets freeze, black holes slowly evaporate, losing mass to a drizzle of radiation. The universe grows colder, emptier, quieter. Scientists call this the heat death, a misleading name, since it's really the ultimate cold, the final equilibrium when nothing more can happen. Entropy wins. The music stops. But even here, the story isn't entirely bleak. Some cosmologists whisper of quantum fluctuations, tiny random blips of energy that could one day spark new universes, just as ours began. Maybe creation isn't a one-time event, but an infinite cycle, each cosmos blooming, fading, and seeding the next. Maybe somewhere, far beyond our cosmic horizon, another you is drifting through another galaxy, wondering if they're alone. Scientists still argue whether the multiverse is a real physical structure or just mathematical poetry. But either way, it's comforting. The universe might never truly end, just rest. A flicker draws your attention. A lonely galaxy adrift between clusters, like a lantern caught in deep fog. These intergalactic wanderers exist, flung away during collisions long ago. Inside it, stars still form quietly from thin streams of gas. One of them, perhaps, has a planet with mountains, oceans, and creatures who look up at their night sky, unaware of how truly lost they are. You drift closer and watch the soft glow of starlight reflecting off a ring of dust around one of its suns. You imagine the warmth, the sound of wind, the faint crunch of ground beneath your feet, and then it's gone again. Just another echo swallowed by the void. The vastness humbles you. All the galaxies you've seen, all the black holes and nebulae, are just a sliver of what exists, and beyond what exists is what may never be known. The human mind, magnificent and fragile, wasn't built for scales like this. It invents metaphors, oceans, webs, bubbles, just to survive the thought. Yet here you are, afloat in the unthinkable, and it feels peaceful. Maybe comprehension isn't the point. Maybe wonder is enough. The silence deepens, and you become aware of another sound beneath it. Not physical, but rhythmic. The ticking of time itself. You realize it's been running all along, a steady metronome since the Big Bang. But time, like everything else, is elastic. Near black holes, it slows. In cosmic voids, it stretches. Some physicists suspect that even the flow of time might reverse one day, as entropy reaches its limit. Imagine that everything rewinding, stars unburning, galaxies shrinking back into a single brilliant moment. Scientists still debate whether time's arrow is fundamental or just a quirk of thermodynamics. For now, it drifts forward, carrying you with it. You sense motion, again a subtle pull. Ahead, light bends in strange ways, as though the fabric of reality itself has been folded. You've reached a gravitational lens, one of the universe's natural magnifiers. A massive cluster of galaxies warps the space around it, bending light from even more distant objects into arcs and circles. Through it, you glimpse galaxies so far away that their light began its journey before Earth existed. They're fossils of the early cosmos, preserved in bent photons. It's oddly beautiful, the universe observing itself through its own distortion. You pass through that lens like a dream dissolving, and the image fades behind you. Ahead lies more darkness, yet it no longer feels empty. Every point in space hums with potential fields vibrating, particles flickering in and out of existence, energy waiting to become form. Quantum fields, they call them, invisible scaffolds on which everything hangs. Maybe the next universe already sleeps here, waiting for a tremor to wake it. You take one last look back. The galaxies are distant jewels now, faint as memories. The background radiation has faded to black. Space is nearly silent, and yet, somehow, the silence feels alive. Maybe because you know it's not truly the end, just the pause before something new begins. You breathe, or imagine breathing, and the universe seems to breathe with you again. You drift in a kind of twilight, no longer among stars, not yet beyond them. Space here is old, thin, stretched like silk worn smooth by time. The glow of distant galaxies has faded to a faint mist, scattered photons wandering aimlessly through the expanding void. Everything feels slower, quieter. Even light seems tired. And yet, in this hush, something extraordinary stirs. A shimmer, a distortion like heat over desert sand ripples across your view. You lean into it, and suddenly, reality itself seems to ripple back. You're no longer observing the universe. You're brushing against the very equations that describe it. The constants gravity, electromagnetism, the speed of light feel less like immutable laws and more like settings on a cosmic instrument. You realize that if they were just a little different, nothing you've seen, no stars, no galaxies, no you could exist. The cosmos seems finely tuned, as though balanced on the edge of possibility. Physicists call this the fine-tuning problem, and they still argue whether it's coincidence, necessity, or design. Some suggest there are infinite universes, each with slightly different settings, and we just happen to live in the one where life can arise. Others think the laws are inevitable, that reality could only ever unfold this way. You can't help but smile. Either way, it's kind of beautiful. Existence as the ultimate lucky roll of the cosmic dice. As you glide through the trembling light, your mind wanders to the question that haunts even the most rational minds. Why is there something rather than nothing? It's not a question science can easily answer. Even the Big Bang Theory, as grand as it is, doesn't tell you why the universe began, only how. Perhaps nothingness is unstable, destined to erupt into something. Or perhaps the question itself makes no sense. Still, you can't help wondering, if the universe could emerge from nothing once, could it happen again? Maybe it already has, countless times. You move on, following the faint echo of creation like a melody. Around you, the last of the starlight fades. Only background energy remains, a cold, dim whisper, known as the cosmic neutrino background, relics of the first second of the universe. They stream through you constantly. Even now on Earth, trillions every second, ghost-like and untouchable. They are the silent witnesses of everything that has ever happened. You think of all the scales of existence you've passed, from the dance of atoms to the sprawl of galaxies, from black holes devouring light to the slow sigh of cosmic expansion. It's absurdly vast, yet somehow personal. You, a being of molecules and memory, can comprehend it and even dream about it. That realization feels like its own kind of miracle. Below or, maybe above you, notice faint flashes, cosmic rays, high-energy particles from distant galaxies slamming into invisible atoms in the void. Each one a message from billions of light-years away, a tiny reminder that the universe still speaks, even in its quietest places. Scientists still argue whether some of these rays come from beyond the observable universe, perhaps ejected from ancient quasars, or even the decay of dark matter itself. The answers drift just out of reach. Like a half-remembered dream, the silence returns. Deeper now, you think of the Earth again, the small, spinning oasis of blue and white, suspended in black. For all the universe's grandeur, that fragile sphere still feels like the most astonishing thing of all. Billions of stars, and only one so far, has given rise to you. Maybe that's what makes your existence precious. Not rarity, but improbability. You were never supposed to be here, and yet, here you are. You imagine looking back from this endless distance, seeing Earth as a single pale dot fading into dark. Carl Sagan once said it underscored our responsibility to each other, how petty our conflicts seem when set against the cosmic scale. You can almost hear his voice echo through the void, soft and wise, urging gentleness. It fits perfectly here, where the stars have gone quiet. You slow to a drift again, as if space itself is winding down. The hum of creation has softened to a low, steady note, a lullaby written in the laws of physics. The boundaries between you and everything else blur once more. You can feel your thoughts dissolving into something larger, vaster, quieter. There's no fear in it, only peace. The stars are asleep now. Maybe it's time you were too. You float, motionless, in a sea of darkness that feels almost liquid thick with silence. Soft as breath, the universe around you is no longer young. Stars have burned out. Galaxies have drifted so far apart that even their faint light can't reach you. It's the long afterglow of everything that was a memory of existence stretching into eternity. There's no sunrise coming, no dawn to break the stillness. And yet, the absence of light isn't sad. It's peaceful, almost sacred. The cosmos isn't dying. It's resting, cooling, dreaming. You watch as the last remnants of a star, a white dwarf, finally fades into a black dwarf, cold and invisible. For trillions of years it burned with stubborn persistence, and now it sleeps. The elements it forged, carbon, oxygen, iron, are scattered into the endless dark. Maybe one day, in some new cycle, they'll awaken again, reshaped into something new. Another sun, another world, another chance. Scientists still argue whether the universe will ever truly end. Some think expansion will continue forever, leaving only cold emptiness. Others imagine a big crunch where gravity reverses the expansion and pulls everything back together into one infinite point, a reset button for reality. Still others whisper of big bounce cosmologies, where every ending is just another beginning. You don't know which to believe, but the uncertainty feels comforting. Whatever happens next, it won't be nothing. It will be change. You drift closer to that thought, letting it wrap around you like a warm blanket. All things end, but endings are just transitions. Stars collapse into black holes. Black holes dissolve into light. Light becomes memory. Even now, the faintest quantum ripples hum beneath the silence. Possibility never fully fades. It just waits. You realize you've come full circle. You began this journey, gazing at the stars, and now you've arrived where even starlight sleeps. And still, the same truth remains. You are made of the same stuff as the universe. The hydrogen in your blood, the calcium in your bones, the iron in your heart, all born from the cores of ancient suns. You are, quite literally, the universe observing itself and learning to rest. A soft rhythm begins to rise again, the soundless heartbeat of space-time, steady and slow. You listen, and it feels familiar, almost human. Maybe that's because it's been there all along, beating inside you. The cosmos isn't out there somewhere, it's within, humming in every breath, every quiet thought. You let your awareness drift, unhurried, through that infinite stillness. The black fades to a softer shade, more like velvet than void. The laws of physics blur into dream. You can't tell whether you're floating in space or simply sinking into sleep. Either way, it feels right. Now, everything softens. The stars, the light, the sound of your own thoughts, all dimming like a candle flame before dawn. You don't need to follow the story anymore. Just let the universe breathe for you. Imagine the quiet pull of gravity turning gentle, like a slow exhale. The galaxies fade to mist, then to whispers, then to nothing at all. What's left isn't darkness, but comfort, a deep, endless blue that wraps around you like calm water. You feel yourself dissolve into it, one heartbeat at a time. There's no weight here, no edges, just warmth and motion, and the faint memory of light. Every sound, your breath, the distant hum of air, the soft creak of your room, becomes part of the same rhythm. The universe hums, low and tender, as though it's singing you to sleep. Every worry fades into static. Every thought drifts away like dust in sunlight. You're not falling anymore, you're floating. Safe, still. Somewhere far away, a star blinks out, and another blinks in. Life continues, quietly, endlessly. You don't need to understand it. Just rest in the knowledge that you belong to it all, of it, the vast, impossible miracle of being. Your breath slows, your mind quiets. The universe fades to black, and in that perfect, peaceful silence, you sleep. Sweet dreams.